Hey, Code in Place. Super excited to tell you about this week's topics. Last week you learned a little bit about graphics. You also learned about parameters, two great topics. Today we're going to take both those topics and push them up a little bit higher. So first, we're going to start with thinking about parameters to do a little bit of review around how parameters work and information flow, which is a key concept for having information move around in a program. So we're going to start with that. And then later on in the next set of videos, we're going to talk a little bit about how to do animation and graphics. So it's just a great time. To get started, let me share my screen with you, and we will pop on over here to the slides. So here are our slides. And so today, our goals are basically to understand information flow. And if we want to think about understanding information flow, let's start off with an example of a program that actually has some bugs in it, so we can actually see what the issues are when we think about information flow. So here's a little program. As I noted in the comments, the program is buggy, so this is not a program that works correctly, and we should understand why it doesn't work correctly by tracing through it and then figuring out how we can modify the code to actually get a working program. So here's the basic idea here. What we want to have is a main function over here in our main that has some variable that starts with the value 3, and then we'd like to call the function add 5, which we'd like to add 5 to that variable, and then print out the results. But this doesn't quite work the way we think it might work. So let's actually trace through and see what's happening. So when the program starts, we start off with the main program, and the main program, here I'll put main over here, is going to have a variable x associated with it. That's just, as you know, a box that's going to store some value, and it has the name x. And so we start off by saying x equals 3. We put a 3 in the box in main. Okay? Then we call the add 5 function. So we have a function, add 5. And add 5 has a parameter that it's expecting. It's expecting a parameter called x. So it says, okay, I need to have a box for x over here. And what is the value that you're giving me for that x? Well, the value that's being passed in is this x over here from the main function. What's the value of x in the main function? It's 3. So what value actually gets passed to the add 5 function is a 3, and that's the value that gets passed in here for this x that we refer to in add 5. Now, as you already know, the x over here in add 5 and the x in main are different variables. They just have the same name. So if we come over here to add 5, which is now executing, and say x plus equals 5, that's going to add 5 to the value of x and store it back in x. The question is, which x? Well, since this is the add 5 function, it has to be the x in add 5. So it's this x over here. It adds 5 to it. That makes it 8, and that's what it stores in this variable. And then the add 5 function is done. So what happens when the add 5 function's done? That function's done. It's going to go away, which means all of the information associated with that function also goes away. And we come back over here to the main program. And in the main program, x, after we've completed add 5, x still has the value 3. So when we do the print, what we're going to get is x equals 3. And the value of x didn't actually change, because essentially what add 5 got over here was a copy of that value and modified the copy. So the question is, okay, that didn't work like we expected. How do we try to fix this problem? And the way we fix this problem is thinking about the notion of information flow. What we're going to do is we're going to pass some value into add 5, but we want add 5 to give us some information back out, and that information that comes back out needs to be stored somewhere. So what we need to do is update the code, and let me show you a working version of the code, which has exactly that same sort of feel to it. The notion of information goes into a function, some computation's done, information flows out of the function. That idea is what we refer to as the information flow of a program. So here's what's going on here. Once again, the program would start, and so we would have the main function come along. Let me go back. We'd have the main function come along, and main would come along and say, okay, I have main. It has a variable in it called x, and the initial value for that variable is 3. That's executing this line right here. Then, like before, we're going to call the add 5 function, passing it into an x, but notice we're expecting add 5 to give us something back now. So let's execute the add 5 function and see what happens. So when we call the add 5 function, add 5 fires up and says, okay, I'm expecting a parameter x. That's a variable I'm going to store internally. What are you giving me for the value of x? Well, like before, the value of x that we're passing in is the value of x in main, which is 3. That gets passed in over here, and add 5 has its value 3. And then it says x plus equals 5, because we're executing the add 5 function. We add 5, and that updates this x, like before, to the value 8. But now, here's the critical difference. Pay close attention. What the add 5 function is going to do is return that value x. So this 8 over here is going to be returned back when this function's done. Now, the add 5 function is still going to go away, but this 8 is getting passed back from the function. So like before, this function is going to go away, but it's passing this 8 back. And the question is, where is that 8 going to go? And where the 8's going to go is this add 5 function here is giving back the value 8. We're going to store that inside x. Which x is this? Well, this is the x in the main program, which is this x over here. So that 8 that comes back, we store in here. And now, essentially, we've gotten the effect of having the value updated, because the information from add 5 came back out to us through the return, and then we stored it somewhere with this statement. So now when we print out x equals the string version of x, we get x equals 8 is what's going to get printed on the screen. And the program's going to work like we expect. So what's the key idea here? The key idea is that when we want to reassign a value to a variable, what we need to do, if we are using a helper function, is we need to have some value returned from that helper function and assigned back to the original variable. Some people refer to this as the x equals change x pattern. The idea being that you have some function that's going to want to change x. So this would just be the name of a function we call like add 5, and we're passing in the value of a variable that we would like to change. So what this function does is it does whatever computation it's going to do, say like adding 5 or something else. And after it makes the update, it returns that value. That's really the key. And when that value is returned, what we're going to do is assign it back to the original variable, which means that that variable is going to get updated in the place that we called this line. Okay, so that's the key idea. And the way you want to think about this is that when we are passing a parameter during a function call, what's going on is a new variable is being created for the lifetime of the function call. Some new variable gets created to store that value that's being passed in. Okay, and that's going to exist as long as the function's executing. But when the function's done, that's going to go away. And so if we want to have that value reflected back in whoever called the function, we need to return that value back to whoever called the function. And it doesn't matter whether or not this new variable has the same name or not as the original variable that's passed in. The names here aren't what's important. Okay, so even if it has the same name, it's not the same variable. That's the important thing to keep in mind. In the previous example we had, both the parameter we were passing in was called x, and the name of the variable that was the name of the parameter that was being received was x. Even though the names were the same, they were not the same variable. Okay? So if we think about that concept, that's what you want to think about, is the x that's over here in add 5 and the x that's over here in main are two separate variables, even though they have the same name. Okay, and so as a result, the way we want to think about it is the only relationship between the value of main's x that's used when we're calling the add 5 function is that we're passing it in as a value or as an argument to the function that we're calling. And if we want that stored back in, then we need to return something here, like we need to return the updated value of x, and we need to assign that back to x for this to work. Okay? So one other thing you should know, a little spoiler alert, later on in class, and I do mean a little bit later on, we're going to get to this pretty soon, you'll actually see cases that when you pass in a variable into a function and you make changes in that function, those changes persist. As a matter of fact, you already saw an example of that. I'll give you a little hint. We'll come back to talk about it more, but you already saw that with the graphics canvas. When you pass the canvas into a function and the canvas, there were some updates, like maybe some new shapes were added or things were moved around. Those were changing the actual canvas. So we'll let you know when this comes up in different cases so you know exactly when it happens. So the bottom line is be careful. When you're passing something like an integer into a function, you're just modifying a copy of that variable. And if you want to have the changes persist, you need to flow information back out to whoever called that function and store that information. Okay, so let's do a little bit of a review. You just saw something about information flow. So let me show you an example of a program that might want to be something like a bank balance, right? So what we might want to ask the user is for the initial balance in their account. That's how much money they have. We'll just treat that as an integer. And then maybe we want to just allow them to make a series of transactions. So we're going to have a while true loop. So this is going to go on forever. It might get kind of boring, but it's going to go on forever, where we ask the user for a deposit amount and 0 if they want to quit. So at least it gives them a way out. If they enter 0, so if the amount they give us is 0, then we'll break out of the loop. Otherwise, what we're going to do is call the deposit function to add this amount to the balance. Okay, and what deposit will do is it's get an amount and it tries to update the balance. Notice any problems here? Yeah, you might. So what we're going to do is think about what is the problem here, right? Is this balance actually referring to this balance? No, in fact, this is a separate variable, balance inside deposit. So when you try to create a variable, you're creating a new variable inside a function. In fact, what's going on here is that the balance over here and the balance over here are different variables with the same name. So how might we actually think about this? The way we think about it is information flow. If we want to update the balance, what we need to do is when we make a deposit, we need to also pass in to this deposit function the existing balance. And so that needs to be passed in here as an additional parameter. And then when we update the balance, we need to return the new balance. And that means whatever deposit, the new balance amount needs to be put back into balance through information flow in our main program. Now, this is a little bit messy, so you might say, hey, Aaron, can you clean that up for me? Sure, I have the cleaned up code on the next slide. So here's exactly what we did. To our deposit function, we said we want you to pass in the balance that's going to be the balance from the main program. And so deposit needs to also accept a balance. Inside here now, this balance is referring to whatever value was passed in for balance, and it will update it by the amount. And then we're going to return that balance, which is going to bring it back over here. The result of this is going to be the updated balance, and we will assign it to the balance in main. So that's how we have the updated balance. And so the principles to basically keep in mind here are we try to encapsulate information in our functions. It's kind of like you don't want your toaster changing something on your refrigerator. You want everything that your toaster is going to do encapsulated in a few bits of information. And those bits of information should be basically clear, as the data that that function is going to use should either be a constant, it should be a parameter that's passed into the function, or it can be its own local variable that's defined inside the function. But if you want to be able to modify any information and have that reflected after the function's done, you need to return that back to whoever called the function, and they need to assign it somewhere, just like we do here in deposit. So that's how kind of your updated lesson on parameters works. So you can keep that in mind when you're programming. Have fun coding. See you in the next video.